Okay, this video tutorial looks at the mathematical strand of trigonometry, and more specifically we're going to be introduced to what is known as the sine rule. So basically the sine rule is a set of three equations which connect the lengths of the sides of any triangle with the sine angles or the opposite angles. Okay, so the sines of the opposite angles. This allows basically us to find any missing lengths or missing angles, and it's really helpful when triangles aren't right angled triangles because it means that then we can apply this to any type of triangle. So let's have a look at an example question where we might use the sine rule. Okay, so it says here, it says find the value of x rounded to 2 decimal places. So we're looking for this value here. And we know that that length is actually opposite the angle of A. So we're going to be using sine A, and we're going to call x A. We actually have an angle here at sine B of 41, and we have a length opposite, which is 18. So we could call this little b, and we'll call this little a. So therefore, we can say that little a, so I'm going to use this one here, okay, little a over sine a must be the same as little b over sine capital B. In this particular case, little a is my x value, and the sine of capital A is 113. That must be equal to little b, which is 18, over sine capital B, in this case, is 41. So therefore, all I need to do is rearrange this equation to find out what x is. If I times both sides by sine 113, that'll give me x equaling 18 over sine 41 times by sine 113. All I need to do now is put that into my calculator. So that's 18 over sine 41 times by sine 113. That'll give me an x value of 25.26 meters. Okay, so we've looked at an example of where we're finding a missing length. Now let's have a look at some examples where we're finding missing angles. So if we want to look at our first example, which we'll call example A, we know that we've got theta at A, and we've got 63 at B, we've got nothing at C, so we don't need to worry about that. So we could say that sine of theta over 6, because 6 is our little a and 8 is our little b, must equal sine 63 over 8. Again, we just times both sides by 6. Sine of theta is equal to sine of 63 over 8 times by 6. Now, in order to do this, we need to do second function sine. So theta is equal to sine second function of sine 63 over 8 times 6. That'll give us a result. Let's just put that into the calculator. Of 41.93 degrees. And again, we do the same thing over here. We can say this is A, so that's little a. We can say this is B, so that's little b. So we can go sine of theta, over 17 is equal to sine 23 over 8. Again, sine of theta is equal to sine 23 over 8 times by 17. Therefore, theta is going to equal sine second function sine 63 over 8 times 17. We put that all into our calculator. Oops, not 63, that's 23. And that's going to give us an angle of around about 56 degrees. Now, just by looking at that, we know that 56 is incorrect. All right, but we also know obtuse angles and acute angles using sine can have the same value. So therefore, theta must equal 180 take 56. And that gives us an angle of 124 degrees. Okay, so what I'd like you to do now is I'd like you to have a go at some practice questions where we're trying to find either the length or the missing length, or the missing angle using the sine rule. When you think you've got them correct, please continue with the answers and we'll see how you went. Okay, so let's see how you went. In our first question, we have an angle of 108 degrees at A, therefore x is our little a. We have an angle of 48 degrees at B, therefore 9 is our little b. So we can say that A over sine A is equal to B over sine B. Therefore x over sine 108 is equal to 9 over sine 48. X therefore is 9 over sine 48 multiplied by sine 108. If we put that into our calculator, we end up with x equaling 11.52 centimeters. In our second example, we have sine of capital A over little a is equal to sine of capital B over little b. Therefore, sine of theta over 107 is equal to the sine of 70 over 138. Sine of theta is equal to sine of 70 over 138 multiplied by 107. Theta is equal to second function sine of sine 70 over 138 times by 107. If we put that into our calculator, gives us approximately an angle of 46.77 degrees. And we know that it's 46.77 degrees because the angle in the diagram is clearly an acute angle.